Welcome all. For today, our topic is recursion. What is recursion? When a function calls itself, this thing is called recursion. And that function which calls itself is called a recursive function. Using recursion, we solve many problems in computer science, and it is a very helpful tool. So, what do we mean by calling itself? For example, I have a function int, and there are certain lines of code in this. Then somewhere over here, this function is calling itself like this. This will be called recursion because rec is a function itself, and inside in the body of the same function, it is calling itself. Which problems in which problems do we use recursion? For example, there is one problem is that of finding the factorial of a number. We have a function which on which we pass 5 to find the factorial of 5. It can do something like that. It can say that the factorial of 5 is 5 into, then it will call the same function for 4, and then this may get repeated. So it will become 5 into 4, then for 4 factorial same function will be called, and then that function will do 4 into 3 factorial. This way this process will continue. Again 5 into 4 will remain as such. For finding 3 factorial, the function will do 3 into, and then it will call itself for 2. Then in the next step it will be 5 into 4 into 3. For 2, the function will do 2 into then 1 factorial, and this process will continue. And obviously we need some stopping criteria, a point where this will stop, otherwise it will continue. So for stopping that, I will put 5 into, this is will be like this, 3 into 2 into, so I may put a stopping criteria like that. When we reach 1, don't call the function again. Just 1 factorial we know is equivalent to 1. You don't need to call that again. So if it is 1, don't call the function again, just write 1. So we will get this figure, which is just a mathematical multiplication, and we will get that. So if we see, it will be 120. 5 into 4 into 3 into 2 into 1. So this way the recursion works. Now let us write code for doing the same thing. So we have to find factorial, but we have to do the same using recursion. So the problem at hand is use recursion to find factorial of a number. Right? Let us start writing code for it. So let us say I have a function here. I declare a function int factorial. So I call the function as factorial. It is a programmer defined function, and this function will find the factorial of a certain number. So that number will let that be an int will be and then we go to main, and we start writing that. Let us take a number, for example int, we have a number x. So let us ask the user to enter the number, enter a number for which it wants us to find the factorial. We scan that number, we store that number in x. Now let us call the function factorial and pass this x to that. The job of this function is to find the factorial of this x. Obviously after we call it and it calculates the factorial, and in return it will give us some value. So let us say in return it gives us an answer, and we store that answer in ans. We just have to then print this answer here. So we can write printf percentage d, what is the answer, or we can write it like this: the factorial of percentage d is percentage d. So the factorial of x is ans, and our main part is done. Now we will write the function factorial, we will define it, and obviously this function is receiving an integer value x from here. So let us store that value in integer n. So we have a function factorial in which there is a variable n. The value of x will be copied to this n. Now after this we have to do the factorial thing. So we know that the factorial of n is equivalent to n into factorial of n minus 1. This we know, and this same thing should be written in terms of the code. So this means that the answer, some answer will be equal to n, right, multiplied by factorial of n. What is factorial of n? Factorial of n minus 1. How to calculate factorial of n minus 1? Call the same function, this factorial function. So just call the same function, and now we don't have to find the factorial of n, we have to find factorial of n minus 1. So here the answer will be that the factorial of n is equal to factorial of is equal to n into factorial of n minus 1. And since this a is the answer, we should return the same answer to the main. We should return this answer to the main, and instead of returning a, we can directly write return this thing. So this will be calculated and returned to the main function. Now this thing will continuously happen and we will get an answer. That is good, but we must put a stopping criteria here, because otherwise it will calling itself will be done indefinitely. So what will be the stopping criteria? Very simple. We will say that if this n is greater than 1, fine. If this n is greater than 1, then it should be like this, fine. If n is greater than 1, then do this recursion thing. But if this n is equivalent to 1, then you don't need to do this. You just return 1, because we know very well that the factorial of 1 is 1. So this recursive thing will continue. First it will be n into n minus 1, then again an n minus 1, then again an n minus 1, till a point will reach that we will reach 1, right? Greater than 1 up to 2 this will happen, but when we reach 1, that means you don't need to again call the function factorial. We know that for 1 the answer is 1, because factorial of 1 is 1, so the answer there will be 1. So this thing will act as a stopping criteria for the recursion. Here this is the recursive call, and this else will act as a stopping criteria to this recursion. So we are done. Let us save this program as fact recursion.c. Compile, run, enter a number, for example enter 5. The factorial of 5 is 120.